to the channel. All right, thank you so much for joining us again on this channel. All right, so without wasting our time, let's get right into the business of today. Now, in this video, we're going to be looking at shell scripting. All right, we want to look at how, what is shell scripting? Why is it important? Why do we need it? But before we delve into shell scripting, there are certain commands that we also need to understand as well, right? Now, shell scripting, like any other programming language you may have heard of, it's basically a way to automate your task in Linux, right? So if there are things that you do repeatedly on your Linux machine or on your Linux server, shell scripting provides you a way to basically automate, all of those things. So whatever it is that you repeat day in and out, instead of typing the command on your terminal every time, you can pull that command in a file, all right, and then the file can be given an execute permission, which allows you to run the file, all right, as a shell script. But before we delve into that, let us try and understand, certain commands that we didn't, we've not touched on that are needed or necessary when it comes to writing a shell script. Now, what are these commands? Now, first of all, let's start with some, commands that we can use to get some system information, right? So, for example, if I need to check my hard drive, okay, for example, if I need to check what space do I have left, what space do I have available, and all those kind of things, what have I used, okay, what is the total size of my hard disk drive, I can use df, all right, for that. Okay, now just typing df will give me, all right, all of these information in bytes, which I can make sense of this information as is, right? Now, like I have taught us, every command in Linux can be used with an argument. Okay, so if you do df-h and you press enter, now, -h here means human readable, which means give this data to me in a way that I can understand. So that is what -h basically means, human readable. So now I can see that my disk size is 6.8 GB. All right, you can see that right here. And I can see from here that I have used 1.6 gig of the 6.8. And what is available to me is 5.2, and I can see that the use is basically 23%. So which means I have used 23% of my disk drive. Now, in the same vein, there's also the command called free. So if I press enter, now that command is also going to show me my memory, the total size, the used size, and the free that is available. Now, again, if you look at this information, it is not irreadable because it is in bytes. That means I have to start calculating everything. But of course, you can get this information in human readable form. Now, if you think that if I do free-h, that will do the magic, then you may be wrong. Because if I type that in, all right, now, it gives it to me, of course, in a way that I can still make sense of it, right? I can see 957 MI, 329 MI, 479 MI, right? It's still interpretable. It's still relatable, right? But then there's a better way. So if I do free-m, I think that's going to give us something better, right? So if I press enter, now that removed all of the MIs that you see there. So now it gives me basically, all right, 957. So I know that, oh, this is 957 MB. Now the only difference here is that this -h gives us MI. So that I know that that is in megabits, but -m gives us what? Just the value. Okay, so both of them will still do the work, right? But of course, in most cases, you always see it as free-m. So whether it is -m, whether it is -h, what is important to us is that we can interpret the data or the output of our commands. That is what is important to us. Okay, so free-h, free-m, it's basically just to give it to us in a human readable format. Okay, now there are commands in Linux that you can actually use together. Okay, so for example, free-m will give me, all right, my memory information, and will also give me the swap information. Now, what if I'm not interested in the swap information? I am only interested, all right, in the mem. So it's just the mem line that I'm interested in. Okay, so how do I do that? Now, if I say let's say -h now -h is going to give us an output. We're already aware of that, right? So -h will give me these outputs. That is clear. But now what I need is just this line. Okay, that's the information that I need. Okay, just that line is what I need. Okay, now how do I get that? Because I mean, there's no way to actually just do that here. So what do I do? Now there's this pipe symbol that you have on your keyboard where you have the backslash. All right, there's a pipe symbol there. So put it there. Now that's the pipe symbol that you see on the screen. Now this pipe symbol is basically, all right, in Linux to say that the command on the left is going to generate an output. Now, I want that output to be passed to the command on the right. Okay? So, which means the result that free-h is going to give to me, I do not want it as is. I want to filter the output. Is that okay? So I want to do what? I want to filter the output. So I don't want just what free-h is going to give to me, but whatever the output is, I am looking for a particular information. So I want to do some filtering. So what do? I use the command called grep. So grep basically means, it can be used to filter. So it can do something like, okay, just give me any line that starts with mem. So anywhere you see mem, that's exactly what I'm looking for. So I'll come here and then I'll say mem. So mem is written in capital, right? M-E-M, and then I press enter. Now look at that. It gives it to me, all right, just that line is what was displayed to me. So free-h produced all of the information as it relates to the memory, but with grep, I can filter exactly what I want, which means I'm not interested in the whole thing. This is just the line that I want. So free-h will give us the necessary output, but grep can help us to break that output down and basically just give us, all right, what we want. So in Linux, that basically is filtering. So you're filtering the output. Okay? So that is exactly what grep has done for us. Now, there are other things that grep can actually do. Now, the grep command can do quite a number of things. For example, you can not just, use grep to filter the output of a command. You can also use grep to read a file, all right? So, for example, we've used cat in some of our videos, right? So if I say cat, for example, etc /fs tab, for example, and I press enter, now the cat command will read the content of that file for me. All right? So it's going to display to me. Now with the grep command, I can actually use the grep command to filter, all right, this particular file. So for example, I'm only looking for any space where you have root, for example. Let's say that's what I'm looking for. So what do? I can say grep, right? And then I say /etc/fs tab. Now that is not complete, right? So I have to go back. I'll say grep. So what am I looking for? I'm looking for anywhere that root is mentioned. So I am looking for root inside of this particular file. So that's what this is, right? So grep can read, all right, and then filter for us specific information inside of a file. So grep is something that works with commands. It also works with what? With files. Okay? So if you press enter, now look at that. It basically gave us where we have root and then showed us all of the lines as far as the root is concerned. Right? So for the purpose of filtering, grep will do that for us. And you can use it in a number of ways. In fact, you can have multiple grep lines, all right, multiple, all right, pipes, depending on the information that you're looking for. Is that okay? All right. Now, you can also use grep in another way. If I'm trying to do the same file, for example, if I want to view the same file, right, like cat, and then I say fs tab, for example, I can also still use grep to read the file. Remember, cat is going to print out an output, all right, of the fs tab. Okay. So if I say cat etc fs tab is going to print out something for me. So I can still take the output of the cat command and then use grep to filter it all the same. So I can come here and put the pipe symbol and then say grep and then say root. So this is the same thing as grep root that we saw here. So this command here is the same thing as what we have here. All right. So here we're using grep to read and to filter. Okay. But here we're using cat to read and then grep to what? To filter. So you can use it either ways. So if I press enter right here, if I just press enter, it's going to give me the exact same result. Okay, so I can use cat to read the file and then use grep to filter a particular information in the file, or I can use grep, all right, to just say, this is what I'm looking for inside of this file. And then grep will go ahead, look into that file. If it finds something that matches, all right, what we supplied, and then it's going to give us, all right, the line that contains exactly, all right, what we're looking for. Is that okay? Now, let's clear the screen. Now, there's also another command, all right, which is also very important. It is called the file command. All right, it is called what? The file command. Now, sorry, the find command, rather. The find command. Now, what does the find command do? It is also a command that you can use to search, all right, for file in your system. For example, if you have a file that you're looking for and for some reason you can't seem to remember the location of the file, all right, you can use the find command to find that file. Okay, so it is a command that is also very used, all right, in Linux, particularly when you are looking for, all right, files, or you want to search for something and then you want to perform some operations, all right, on that thing. For example, we're going to be looking at a shell script as we go on that can help us to actually find log files and then, delete them after maybe a number of days, right? So for example, if you have a log file that is maybe like 7 days old, you want to delete them automatically so that you can reduce the load on your disk drive, right? So you can use the find command to actually do that. Okay, so we're going to be seeing that as we go. But let's take, all right, practice on how to use the find command. All right. Now, the find command, of course, like every command in Linux, has different arguments that can go with it. Okay, so if I do find, of course, I can do -help. Now it's going to show me a lot of, all right, arguments and, options that can go with this command. Okay. So here, if you look at what you have here, all right, you have find -h, and then you have these other options right here. Okay. So now it has different options that you can use with it, right? So there are different expressions, there are different things. All right, these are some text patterns. Maybe you're looking for something that has spent a number of time, on the system, a lot of different patterns that you can see here. So with the find command, you can also execute commands, all right, with the find command. That would also be acceptable. All right, so I'm just showing us this to know that there are different options. But let's see how we can use, all right, this find command. Now, let's say I want to find something, all right? So let's say I'm looking for, let's just say I'm looking for this particular file. So let me just say genome, okay? So let me see this is what I'm looking for, right? And let's say just a file that I can't find, but I know it's available on my system. So how do I get this file? Okay. Now, when you use the find command, you use the word find. Now, you have to specify the directory where that contains what you're looking for. Okay. So now if I do /, basically I'm saying I'm looking into my root directory. Now remember, in the root directory, there are a lot of what? Other directories. Because in the root directory, you have the bin, you have the USR, you have the etc, a lot of other directories in the root directory. So basically what I want to do is I want to do a system-wide search, because I don't just know where this particular file is, whether it's in my etc directory, whether it's in my USR directory, I don't know. So I want to use the find command to do what? A system-wide search for this particular file. So what do I do next? I'll use the flag or the option -a name to specify the name of what I'm looking for. Now, whatever it is you're looking for, you have to put it, in, double quotes, and then let's say this is what I'm looking for. So I'm looking for anything that has genome, and I can put asterisks, right? So which means anything that starts with genome, I don't mind what the extension is. It can end with .txt, it can end with .sh, it can end with, but at least I'm looking for something that has the genome, all right? So, and whatever follows after that, I don't mind, but this is just what I'm looking for, right? So I close my double, quotes, and then here I can put a thing -print, basically to print it out on the screen for me, to see. So look at the pattern. Find. So what am I finding? I'm searching where? The root directory. So what is the name of what you're looking for? You specify that. And then the print basically means you want to print it out on the screen. So I'll press enter. Now look at that. Now that command is going to search, every file and every folder in your root directory. Okay? It's going to do what? It's going to search for every folder or directory in your root directory, looking, for anything that has genome. So you can see here, it searches my USR, share time, whatever. Now these other ones, it says permission denied because I didn't run it with sudo, and these are directories that you can't, mess with them. So that's why you're seeing all of these errors, right? That's why you're seeing all of these errors. Okay, but you can see that the find command actually searched every directory in the root directory. It didn't spare any of the directory. And that is because the command we specified is basically what? /. And that means we're looking what? In the root directory. So any directory that is in there, the find command is going to comb those directories and then fetch for us, what we're looking for. Is that okay? Now, all of these errors that we have, if I want to, I don't want this error to display on my screen. All right. I basically just want, any error that comes up, I want it to be passed into what you call in Linux, the dev null. Now, dev null in Linux is more like a recycle bin in Linux, where anything that you put in there is basically gone. Okay, so there are informations, there are outputs, that some commands generate that we do not actually need. So what we do is to just pass them into the dev/null. Okay, so that's what we do. So if I want to type that command again, this command again, now I can do something. I can say to, greater than sign, and then I will say /dev/null. So what am I saying? Now, the 2 that you see here and the greater than sign basically means, if there's any kind of error in the output, basically direct it to what? To dev/null. So /dev/null in Linux is actually like, what I can call a place of no return. Because anything that you redirect to that particular location is as good as gone. You can't recover it. All right? It's basically gone. It's more like an empty hole where anything you throw there is just gone. All right? So if I press enter, now let's see what we have. Now look at that. You can see that all the errors that I saw earlier was basically passed into what? The dev/null. Right? But of course, if I go to the dev/null, I'm not going to see anything because like I said, it's like more like a journey of no return. Okay, so anything you put into your dev null is as good as gone. You can recover it, you can get it again. So all of those directory that returned error the first time you can see basically that we're not seeing them again, and that is because the 2 and the greater than sign is a command in Linux that is used for redirection. But 2 in this case basically means if there's any kind of error in the output, all right, do not bother to show it. Basically, just ignore the error in the output and just give us, all right, the actual, all right, results that do not contain any error. So if you look at what you have here, this result contains the folders and the directories. Well, if I say folder and directory, I'm using them interchangeably, okay? So don't get confused. So the folders that our user can access, all right, they are the ones that we can see here, all right, and they are the ones that, it's not giving us any error. There are other directories that are not displaying because, the user doesn't have access. But here you can see that it gave me everything that has to do with genome. All right, genome 256 color, genome 2012, genome RH80, RH72, anything that has genome, right? And of course, you can see. So, and the one thing about the find command is that it won't just show you the file, it will show you the absolute path, all right, where you can get the file exactly. Okay, so you can see here that is giving us what? The absolute path, all right, to this genome 256 column. So this path, I can note them down. So the next time I want to find my genome, all right, I don't need to use find again. I can just go directly to this absolute path, right? Because the genome command has given me what? The absolute path, all right, to the file. So that is one thing about the find command, all right? That's one thing about it. Now, the difference between the find command is this. With the find command, you can search for any file within your system, all right, in any directory. So it can be the root directory. It can even be in your home directory. You can search for any file. Another thing about the find command is you can also execute commands alongside, all right, the find command. Okay, you can execute command. Like I said, we're going to see, all right, a shell script as we go on. All right, so, but the grep command on the other hand can help you to filter, all right, a file. It can help you to filter the output of a command as well. Okay, so there are use cases for them. So if I want to filter a file, maybe an output something, right, I can actually use grep for that. But if I'm searching my system for a file that I've lost, I can use find for that. And if I want to execute a command alongside my search, right, I can use find to do that as well. So find gives me the ability to execute command alongside, all right, what I am searching for. Is that okay? So that is one difference between the two of them. Is that okay? All right, so let's clear the screen here and let us move on. Now, another thing that I wanted to touch on as we build up to, writing some shell script is the concept of variable, all right, in Linux. Now, what exactly is variable? Variable is basically you passing a value, all right, to a string, or maybe a number, for example. So I can say name equals Bola, for example, right? Name is equal to Bola. Now, name here is what? It's a variable. It's a string. Bola, on the other hand, it's a value that I'm assigning to the name variable. Okay? So if I press enter, so how do I recover this variable? Right? How do I make use of it? So I can use echo to view the variable. But if I say echo name, now echo is just going to echo the same thing, like echo name. So just echo name. All right. Just like when you speak into the mic and say, oh, hello, 1, 2, right? The speaker is going to repeat what? Hello, 1, 2. That's what you're going to hear. So echo is also the same thing. So if you say echo this, it's just basically going to repeat, all right, the value that you put in front of it, right? So if I say echo 1, 2, 3, for example, it's just going to give me 1, 2, 3. So the echo command is basically a command that you can use to print something on the screen, repeat something, and all of that, right? But if I actually want to get the value that I've assigned to the name variable, what do? I basically say echo, and then I precede that variable, all right, with a $sign. Okay, so the variable has to be preceded with what? With a $sign. So now, if I say echo, and then I say name, and then I press enter, then it gives me the value of that variable, which is $, in this case. Okay, so when you're referencing a variable in Linux, you must precede your variable with what? With a $, and then the name of the variable. Okay, so if I say, let's say DevOps, we can say DevOps equals, all right, let's say Ansible, for example. Then I press enter. So I can come here and say echo $, and then I can say DevOps, right? And then it gives me the value of that variable. But if I come and I say echo DevOps, all right, it just gives me DevOps. So the $sign that precedes the name is basically what tells the shell that this should be interpreted as what? As a variable, not just as a name. Is that okay? All right. Now, in Linux, there's also what you call command substitution. Okay? There's what you call what? Command substitution. All right. Now, we've seen free -m, right? We've seen, what that is. It displays the value of our memory and, information related to the memory. Okay? Now, what exactly is command substitution, right? What exactly is command substitution? Now, for example, if I say mem equals free-m, for example, all right, of course, it's going to give me an error. All right. So now if I say, all right, let me just say, let's just say free, right? Of course, if you use the free command, it's still going to give you something. So let's say mem equals to free, right? Now, if I do echo $mem, it's just going to return to me the name free, okay? But what is a command substitution, right? What is command substitution? Now, there are two ways to actually substitute command in Linux. So let's look at it. Let's look at both ways, starting with the first one. Now, command substitution is more like you assigning a value to, all right, a string. Okay, more like you're creating a variable that is holding a value, right? It's more like it. But command substitution is basically used when you want to substitute maybe the output of, all right, a command, okay, into a variable, all right? So which means, for example, in this case, if I say free-m, of course, it's going to give me my memory. So that's a command. Now, I want to substitute this value into, all right, another thing. So for example, let me say mem, for example. So let's say memory, okay? Now, I would say memory, all right, equals, now I'm not going to say free-m, rather, I'm going to say equals, I'm going to use my backtick, okay, backtick. That's like the first key before number 1 on your keyboard, right? So I'll say backtick and I'll say free-m, and then I'll close that with another backtick. All right, so let's press enter and let's see. Okay, now it didn't return any error. So now if I say echo the $, and then I go memory. Now look at what you have. What did it give to us? It gave us the memory information, though even though it didn't display it properly, but you can see that a command substitution has basically what? Taken place. Okay, a command substitution has what? Has taken place. So now, anytime I do echo memory, all right, it's basically going to give me the value of free-m. All right, so anytime I do echo memory. So now, with this, I don't necessarily have to do free-m every time. I can just say echo $memory, and I can use this in my script as well. Is that okay? I can use it in my script as well. All right, so let's go on. Now, that is one way to do command substitution. So what's the other way to do command substitution? The other way is to say add, all right, let's just say add disk equals, now, $ open bracket, and I'll say df-h, and then close bracket. All right? So that's the second way by which you can do command substitution. So I'm substituting the value of df-h, all right, into the add disk variable. So anytime I reference the add disk variable, it's basically going to give me the value of df-h. So if I press enter, I can come here now and say echo, all right, this, and then I say my add disk, right? Now you can see that is giving me, all right, the value of df-h, all right, in all of this form. Now, even though it's not displaying it properly, that's fine. But the idea that I wanted to take away from this is the importance of command substitution. All right, so don't bother about, oh, he's not displaying it properly. Why is he not displaying it like that? That's not the point. The point is to understand how you can substitute command in Linux, because we're going to be using this by the time we get to the shell scripting project. All right, we're going to be substituting commands. So I need you to know how it is done, all right, in Linux. Is that okay? Now that we have done, all right, a few things, of course, there are other commands that we're going to be looking at, other conditionals, like the if else, like the for loop, or we're going to be looking at all of these things, okay? But we've covered a few basics. Now, I want to take us to, all right, shell scripting now. Now, what is the purpose of shell scripting? The purpose of shell scripting, like I said earlier, is to basically automate, tasks that you do repeatedly, right? For example, if every morning when you resume in the office, right, you have to do, let's say, df-h to check the hard disk available space and what you have used, right? Let's say you do this every morning. Okay, and you also have to check the memory, all right, -m, to check what the memory is, what is available, and you have to check maybe PS, all right, aux, for example. I mean, you want to check the processes, all right. So let's assume that these are the things that you do every day when you get to work. Now, typing all of these things on the terminal is time consuming, right? Particularly when you are dealing with like hundreds of systems. Okay, you're dealing with 10 systems, 20 systems. I mean, you can't go from one system to the other, typing df-h, free-m, or IPS aux. I mean, on 100 systems, that's going to be crazy. Okay, so how do you automate that process? How can you run, all right, a command on one system, and then you can also use the same command on any other system, regardless of the operating system? Which means I can have a command that works on Linux, and at the same time, the same command works on what? On Amazon Linux, on Red Hat, for example, just using the same script. Now, that is basically what shell scripting is about. So everything that we do day in and out can be what? Automated using shell scripting. Okay, so let's take an example. So how do we even begin with shell scripting? Of course, you begin with a simple file, right? Just a file. And what shell scripting is basically is that all the commands you will have run on your terminal, you basically just put those commands inside of a file, make the file executable, and then you run it. That's what shell scripting is. So shell scripting is basically all the commands you will have run on the shell. For example, this find command that I will have just, that I will have executed here, for example. All right. So something like this that we did earlier, that I'll have executed here. Okay. And then I've print. Now, this is something that I can put in a file and execute, right? Instead of executing it on the terminal, on the shell itself. I can actually put it in a file and execute it. So let's see how we can write a shell script. So first of all, file. So nano, all right? So let's say nano first script. Now, you can decide to end your script with .sh. It doesn't matter, right? Whether you end it with .sh, whether it doesn't end with .sh, what is important is the content of that file. That is what is important, right? So the extension of .sh is not actually mandatory, okay? So you can end it with .sh and you can decide to just say first script and that's all, okay? That's still acceptable. So you press enter. Now, when you're writing a shell script, what are the things you need to pay attention to? Now, every command that you run in Linux runs, all right, at the shell prompt. So when you log into your Linux, you have the $, and then you have the shell prompt. All right, so anything you put into the shell prompt will what? Will interpret it and then give you, the results, all right, based on the input that you have supplied. Now, in order for the prompt to be able to execute our file, which is a shell script, we need to point, all right, in that file, okay, to the interpreter, which means the file must have an heading that will basically suggest to the shell script terminal that, oh, every command in this file should be executed using this, all right, terminal, all right, or this particular file, for example. Okay, so in shell script, you have what you call a shebang. That's what it's called, a shebang. That's what you call it. Okay, so here you have your hash, you have your exclamation, and then you have /bin /bash. Now, every shell script that you see, all right, has this first line. There's no shell script that you will see that does not start with what? With hash, exclamation, /bin /bash. Now, what is the purpose of this /bin and /bash? Basically, I am telling my interpreter, which is my terminal, to execute the command below, all right, this line using what? The bash interpreter. Now, the bash interpreter is basically the name born again shell. That's what it means. So what I am doing here is basically telling my shell prompt to say that any command that is below this line, all right, should be executed, all right, using the shell prompt. Which means whatever it is that I type below here is going to be interpreted, all right, normally, as if I'm running it on the terminal. Okay, so that's why you need this line. So for example, now if I come here and I say make directory, okay, all right, so let's say make directory -p, and then I go shell, I go DevOps, I go Ansible, all right, I go Terraform. Now this is a command, right? Now if I come down here and I say touch, all right, and I say file 1, now remember these are the commands that we ran earlier, right? So when I say file 1.10, and then I close that in the parentheses, and I say txt, for example, what's going to happen? It's going to create a file, right? So now if I come down here and I say cp, all right, file, okay, so I want to copy anything that starts with file. I want to copy it inside of the shell folder, right? Now, all the things that I'm typing are basically things that we've done in the shell prompt, right? So, but then I am putting all of those things now inside of a file, right? So I can go a step further and say, you know what? I want to remove, all right, file 10.txt. Okay? I want to remove file 10.txt. Is that all right? So let's see what will happen with this. So I go, I save it, and then I exit out, right? So now if I do ls, my first script is here. Now, but when it comes to shell scripts, you have to give the file an execute permission. So now if I do ls-l, now you can see that the script, of course, is a file, but there are no execute permissions right here. So when you want to execute a shell script in Linux, that file must be executable. Okay, so it's not just enough to be readable, but the file must be executable. And so right now, I don't have any execute permission for user, for group, and for others. So I need to do that. So the command to do that is chmod +x, and then the name of the file you want to make executable. And then you press first script. We press enter. So now if you do ls, now the file is green, telling you that this file is now what? Is now executable. Remember, this is similar to what we saw in our usr/bin, right? So when we did ls-l, all right, usr/bin, okay, we also saw the same thing. So all of these green files mean what? That they are what? Executable. Okay, so that is exactly what we have done with this one as well. So the file is green, it means it is executable. And if you want to confirm further, if you're doubting, you can also do file, all right, first script, and then you press enter. And then the command tells you that this is what? A born again shell script. And it says ASCII text executable, which means this file, all right, is a shell script and it is what? Executable. So how do you execute a shell script? How do you do that? You basically say dot slash and then the name of your script. So dot means this current working directory, / means this is the file that I want to execute in this current working directory. Because I mean, if you just go ahead and just say, all right, example, and you press enter, it's saying command not found. So it's going to be seeing it as what? As a command, not a shell script. So in order to execute it, you say dot slash first script. And then you do what? You press enter. Now, we didn't see any outputs, right? As in, it was as if nothing happened. Okay? But let's do ls. Wow, something happened. I mean, the files were not there before, but now they are there. Okay? So if I do ls and then I go into the folder, remember we copied in the script, we did, cp, copy anything that has file into shell, right? And then I go there and I say, wow, it's actually copied. Now, the reason why we didn't see any output after we executed the shell script was because all of the commands that we put into the script are not, all right, commands that generate any outputs. I mean, your CP does not generate an output. Your mkdir does not generate an output. All right, your rm does not generate an output except there's an error. So that is the reason why we didn't see what? Any output. Because these commands that we put into the script do not generate any output. They basically just run and give us the result. But right now we can see that even though we didn't see any output on the screen, the commands actually executed as we specified it in what? In the script. So you can see that the same commands that you type on the terminal, right, on your shell prompt, the same commands can be put into a file, all right, and then you make the file executable. And then when you run this file, which has become a script now, all right, it can produce the same result as you typing it on the shell prompt. Okay, so that is basically what a shell script is. So now that we understand the basics of shell scripting, why we need it, we're now going to delve into, all right, deeper realms, all right, in shell scripting. Okay, so we're going to look at different commands. We're going to look at some other commands, all right, as we go on in the course of this class. So let us pause here, watch this, learn from it, and then if you have any questions, put it in the comment section and we'll try our best to answer your questions. Okay, so thank you so much. Don't forget to subscribe, don't forget to like, and don't forget to share this video, all right, to as many, all right, as to as many people as possible in your cycle. Okay, and then I'll see you in the next video where we continue our learning on shell scripting. Thank you and see you in the next video.